I've got some goodies. And we know what that means, don't we? It's project time. Right, let's see what we've got here. Alright, if only there was a way that this would magically assemble itself. Wait a minute. I've got my magic wand here. It's a biro. Let's try that again. What the f***'s sake? Oh, I know what's wrong. I'm forgetting to say the magic words. Izzy Wizzy, Bob's your auntie. Well, that was easy. Greetings, the Astro 30 here, and if you've guessed by the title, we're building a dummy load 8 ohms for testing amplifiers. I've also received this package from one of my patrons, Danish Dart, yet again to the rescue. Thank you, mate. Merry Christmas to you. I know what it is, you guys don't. It's sort of related to this project, it's sort of not. But we're going to take a look at what's in this box. Now I've gone ahead beforehand and already cut the tape so I can get the box open. So we open a Z-box. Z-box. Ooh. What have we got here? We have I know what this is. DSO shell, like similar to the one that I have from the JYE Tech oscilloscope. That's wonderful. I do need another oscilloscope because all my stuff is in storage, as some of you might already know. Don't know if this was already built or he built it. Maybe you can put a comment in the video there, Danish Dart. Did you assemble this or did it come pre-assembled? But thank you for that. Not sure what that thing is.
Surprise, motherfucker!
Oh my lord. I can't pronounce that, but it's a digital multimeter. Wow. That is amazing. Wow, thank you. I'll have to find an IEC cable for that, but I'm pretty sure I've got one. Never mind. That's the power adapter for the DSO. Those are obviously the test leads for the multimeter. I'm not sure why that's there. That'd be for this, the MT8208 graphical multimeter. So there's a user manual for this. Thank you for sending that. That makes this more complete. And what I'm after is this little thing, which is quite light. But let me get this box out the way and put this one on the desk. Okay, so it's like Christmas has come early for the Astro 30. That actually rhymes. Yes, I'm using scissors incorrectly. It's a T12 soldering station. Ooh, thank you very much. So here's the control unit. It runs on 24 volt 4 amps. Actually, that's changed, because the one in the picture I saw online said 3 amps, so they've changed it. This uses one of those power adapters you use on a computer, an all-in-one desktop, laptop. However, I've got one that's connected to the computer just in the top of frame here. That's a 19.5 4.5 amp. I'm hoping there's enough voltage to power this. We will find out in a second. Okay, so there's the end of my power supply cable for the computer. The socket's way too big, but the thing about this is it's universal. It will fit different types of models because they give you adapter kit here. Hee, found it. Okay, now I need to plug the cable in, so I don't really want to lose this one, so I'll put that there, and this just plugs in there like that. Now I'm going to turn it on. I'm not sure why it's doing that. It is getting hot. Okay, I got that to stop beeping by... smoke coming off that. Got that to stop beeping by turning that control up a bit. Oh yeah. Yeah, now we're in business, mother... Before I get too excited, I'm going to take a look at this die-cast aluminium box. It's JCar Catalogue HB5067, and it's 1119 by 93.5 by 34 millimeters. It's a really cheap looking design, but I'm going to open it up somehow. Let's have a look here. There we go. I really wish magic was real, because then I could actually have this assembled without having to do anything, like do the manual labour, but that's not going to happen. Well, help me to understand why I can't get this open. Open! Thank you. Right. Okay, so that's what that looks like. There's the screws for it. And it's a fairly thin, what's the word, gauge of aluminium here. It looks, I'm not sure what the gauge would be. It's not 18 because that's only like a millimetre thick. This is like 2 millimetre thick. And instead of guessing, why don't I measure it? So I'll go from the 100 position. Yeah, 2 mil. And that's nowhere near 90, well actually it's 93.5, wasn't it? Yeah. By 119 by almost 40 millimeters high there, because I think they're going on the inside area rather than the outside area with that particular measurement. But that's going to form the basis of a heat sink. Now it won't dissipate a lot of heat because it's only a small surface area, but it's enough for a dummy load, so that's what I'm going to plan to do. Is I'll put the resistors in, and well, I'll demonstrate. So basically the idea is there's going to be 2 tag strips, which that's not going to stand up, and I've just thrown that one on the floor. You get the idea. And the resistors are going to go in between them. Get the leads out of the way. In between them, and they're going to sit up against the surface of the aluminium. Probably that side's good enough for that. With some heatsink transfer compound between the resistor body and the die-cast box. And there's going to be 8 of them. And it's sort of like going to end up crossing over. So it's going to be awfully awkward to get 2 of these, because it's going to be 2 wide in parallel, and if I just do that for now, just to get it started here so I've got a fair idea what I'm doing. Okay, I've realised that it's probably going to be awfully tight in there, so what I might have to do is, because that's how the resistors are going to line up together when they're soldered together, the 0.22, sorry, the 2.2 and the 22 respectively. And if you look at it, you could only fit another row of 3 here. I might have to get another couple of terminal strip blocks here, just to give me more space to mount things. So that means on this 5-way, I'm not using the center one because that's going to be in contact with the case. So is the other one, and that can possibly short things out. So I've really only got 3 that I can use. So it'll be 2 resistors, sets of resistors per tag strip. So I'd need another 2 of these, and I'll put another one there, and another one there, and that will solve that problem. I didn't really think about it to a great deal before I purchased, but these are only like $1.80, so it's not that expensive. And when it's finished, that's going to end up being the top, and there's going to be like 4 screws protruding out here. I tried to get countersunk ones, but they don't sell them anymore because it looked better with countersunk, but then again it's only 2mm thick material, so I have to be wary of that. But I might have to go to Bunnings to get the M3 countersunk screws. I only need one's about 10 millimeter long. This should be enough. So I drill 4 holes here. I'll drill a largish hole here and fit a rubber grommet and have the leads coming out, and have a strain relief on the inside using a zip tie or something to strain relief on that side, and zip tie on this side to strain relief here so it doesn't pull in and out of the grommet, and a couple of zip ties along. So there's the rubber grommets, and I'm going to terminate the leads when I find it with these 2 alligator clips. So minus the cost of the heatsink compound, which was $2.50, it comes in at a little over $55 to build this thing. And because now I'm going to have to buy a new couple of tag strips, it'd probably be closer to $57. But that's also including the M3 10mm screws that I've got, plus the nuts to go with it. They're $3.50 and $3.35 each. So you can take that off, it's about $7. That brings it down to $50. So about $52, and you can build this little project. Alright, let's take a minute to discuss the circuit. Please excuse the crudity of this drawing. I didn't have time to draw it to scale or to paint it. Anyhow, okay. It may look a little bit strange, but if you break it down and ignore the rest on this side, basically we've got 2 resistors in parallel with each other, so 22 ohm and 2.2 ohm respectively, and they're wired in parallel as I just said, and that'll bring our total ohms between here and here to 2 ohm. And then in series we have another set of 3 of these parallel resistors. So what we end up with the positive on the left here and the negative input on the right there, we have 2, 4, 6, 8 ohms. So that will end up equaling 8 ohms. And as these resistors are all 10 watts, that's going to give us a total handling wattage short term of 80 watts. Now I have done a separate video of calculating resistors in parallel. I will link it down in the description, but for the sense of completeness here, I'm going to go through it again here. So we've got our R total, resistance total, equals R1 times R2 divided by R1 plus R2, which equals 22 times 2.2 divided by 22 plus 2.2, which equals 48.4 divided by 24.2, which equals 2. Now this is the long way of doing it. There are calculators online to calculate resistors in parallel for you, but I'm just proving that the math works. Okay, and just for the sense of completeness, just so you know that I'm not lying about the math, I'm going to measure the actual equivalent parallel resistance of these 2 resistors, the 22 ohm and the 2.2 ohm respectively. Oh wait, they're backwards. The electrons are going to fall out. So anyway, two ohms, give or take. See, the math doesn't lie. Isn't that special? And I was also lucky because these 22 ohm resistors here, I bought the last 4 at J-Car. There was only 4 there. I was so happy because I needed 4, and there was 4. So I got the last 4. Sorry anyone else that's going to go to Kingston J-Car and find they don't have any 22 ohm 10 watt resistors, because I bought the last 4. I'm so sorry. Okay, so I've marked out where the holes in the top are going to go for the tag strips. It's 30 millimeters up and down that way, and 20 millimeters in from each edge, and that gives me enough room to put 2 tag strips side by side, and enough room between the 2 sets to actually put the resistors in. The tag strips are 50 millimeters long, and the tag's center is at 25, so that makes the math a little easier. So there's about 5 millimeter from the edge on each edge here from the tag strips, so it'll fit just nicely in there and should clear those screw posts. I've also put a mark for the lead hole, which is 46 in from the edge and 16 from the top. Now this is dry erase or whiteboard marker, one of these, so it'll rub off very easily. So after I've drilled, I can just wipe it off with a cloth and it'll come off. I can't leave it on there for days on end because it will get quite solidified and won't come off without assistance. So now I'm ready to drill. Okay, I've borrowed a drill off somebody. I am going to buy my own. I think I've got a like 2mm bit in here, so I'm going to start with that. Hopefully I don't drill into the desk. And I've got a piece of paper here to catch all the aluminium shavings that come off of it. So here we go. I haven't drilled a hole in about 3 years. Now, that's very slow. There's one. Got to do that another 5 times. God, that drill bit must be blunt. But anyway, this is what I meant about the dry erase. See, it just rubs straight back off. Now, one of my holes is slightly off, but I don't think that really matters for what this is. I will clean that up with something properly later, but there we go. Now all I've got to do is just enlarge these holes to the correct size, which is going to be 3mm. Make that 3.2 because there isn't a 3mm. There we go. Now I need to countersink these, and I'm going to use a 6mm drill bit, but at a low speed. That's all I need to do. More on that one. Okay, they're countersunk. Isn't that special? So all I need to do now is ream this out. I'm going to use a 6.5mm drill bit to do that because I don't have a file. I have to make sure I deburr on the inside here too. But to ream that out so the grommet's going to fit through. Alright, that was a task and a half, and hindsight being 20/20, either a file or a stepper drill bit would have made that a lot easier. I have got the hole. It's probably about 7 or 8mm. It's slightly smaller than the grommet, but that's nice, that's good. Got the grommet in, everything's deburred. A bit of crap. So yeah, now it's ready to install the parts in it. Alright, I'm going to borrow one of the case screws because they are countersunk. They're too big. Well, doesn't matter. I was just going to see if the countersink was right, and I dropped the screws on the floor again. Okay, so I'm just going to see if these screws will fit through the hole for a start. Yes, they do. Just want to see how these look lined up alongside each other. These aren't the final screws anyway, they're only just in there temporarily. I've also noticed that this case has got a slight bevel to it, like it's on an angle, but that's fine. Oh, there's plenty of space. Plenty of space. I don't even really need to do this up all the way to prove the point, so I only really guessed those measurements between the two. but I was pretty good, and I haven't done stuff like this in years. So there we go. See all that clearance I've got? That's perfect. There's just enough room here for the cables to come through and the resistors to sit down here. Just got to be careful where this screw is, that the lead of the resistor doesn't come into contact with it when it's going at an angle. Same over here and here, but it shouldn't. So what I'm going to do is I'm going to put this on the other side now to see the distance. Okay. Sorry, my hand's in the way. I know you can't really see much, and it's not that exciting watching me do up a nut. Or try and at least get a nut started. Okay, so that's how much distance I've got if I leave it like this. I can rotate them around 180 degrees so they're facing in. That'd probably work better, but I'll just grab my resistor connection. Oh yeah, I think that'll work perfectly. If I can get one in and started or something. Yeah, that's going to work perfectly, I think. That's great. Well, so all I need now is to solder the resistors together, solder them to the tag strip, so get two more, and then put the wire in, and then I can put the top on and screw it together. But now that I've actually opened the case screws up, I'm going to put them nowhere near where they need to go. I'm just going to lightly thread them into the, well, if I can get it started. What is going on here? Well, that's great. It appears there is no tap in that hole. I can't see one, unless you guys can. No, it appears it does not have a tap in it. So, either it wasn't tapped, or you use this machine screw to tap the hole as you're screwing it in. That's going to be frustrating, as well as annoying. And it doesn't look like any of the other holes are tapped either. So getting that to go straight when threading it in is going to be the challenge. Alright, I'll cross that bridge when I come to it. For now, I'm just going to put the screws that come with the case inside the case and throw them on the floor again, just so I don't lose them for now. Okay, this is a problem when you film multiple projects at once. You tend to lose track of where you were. Okay, I've now got some new hardware. I've got two more tag strips and some countersunk 1/8 of an inch screws. They should be M3, so we'll soon find out. So I'm going to replace these non-countersunk screws in here with those and put those two new tag strips in. But I'll do that off camera because, well, you don't really need to see me doing that. I'm actually curious, even though that these countersunk screws came with their own nuts, I want to see if these M3 nuts actually fit on here, like it's the same thread pitch. Because it'd be nice if it was. If it's not, well, it's not. And I can't seem to get that started, so yeah, they're a different thread pitch. Okay, that's all I wanted to know. They're also bigger than the hole. I'm going to have to drill those holes out, so yeah, there we go. That's what I was going for. I had to re-countersink them, but they're still not quite flush. But it is the top, so it doesn't really matter. And that's what I've ended up with. Now, I've had a change of plans. I am now going to mount each resistor set straight down the line. There should be enough room to clear these screws, and I'm going to put, like in this tag here, that tag there, etc. down the line, and I'm going to use a bit of wire to make the series connection between the resistor sets, because the wire that's going to come out of it has to be cut short anyway on one of the leads, because one end's going to be mounted up here, one end's going to be mounted down there. Okay, so as messy as this is going to be, I'm going to apply some heatsink compound to the underside of the body of the resistor, the resistors, like so. That should be enough, and then put it in through the tag. So I'll do that off camera because it's a bit fiddly. There we go. That was so fiddly and time consuming. Took me about 10 minutes to get them in there, but they're in there. And I had a lot of trouble with these wires not agreeing with me because, well, they're stressing the tag strips. Maybe a bigger box would have helped, but they're in there with some heatsink transfer compound in between the two pieces. I found it easier to put it in, turn it upside down, and then apply the heatsink transfer compound, because I always end up with this shit everywhere. I mean, yeah. Okay, each resistor is in the same order, so it's 0.22, 22 respectively down the line, and they're all the same way around so the electrons don't fall out. So now with all this fidgeting around, before I solder, I'm going to check each resistor pair to make sure they're 2 ohms. It's coming up 2.1, 2.1, 2.1, and 2.1. So when I solder these, I'm going to make sure to push on them to hold them down so I can get this to sit flush to the case, and hopefully it behaves itself. Alright, so we're ready for solder. I will do the interconnecting wires just on the outside of the tag strips after I have soldered the main resistors in. Okay, that beeping's going to annoy the piss out of me, but anyway, let's try soldering with this now. It does actually work, but I think I've got a bit of the heatsink compound in the hole there. Right, well, I've got the resistor pairs soldered in now, and the iron doesn't do a very bad job. It does an excellent job, actually. It seems to be running okay on 19.3 volt. So yeah, now all I've got to do is put the series connecting wires in. This is going to be fun and tedious. Okay, and as messy as that looks, it's functional. I did overheat this wire slightly, the insulation melted, but that's fine as long as there's a connection wire between here. Now if I've done my connections right, the total resistance across these 2 points, shut up soldering iron, should be 8 ohms. .2, close enough. Yay. So now all I need to do is put my leads going into the grommet to the 2 connection points, and this is pretty much, well, basically done. And there we are there, 2 leads. Now to just double check its ohmage. Around 8.3 ohms, 8.2, thereabouts. Okay, so I know that the load is working. So now all I have to do is deal with this top cover, or bottom cover actually. I honestly do not think I've got a big enough screwdriver. That's what she said. Alright. I'm going to go get a bigger screwdriver. Smells funny in here, but anyway, I've got a bigger screwdriver, and yes, you do use the machine screws to cut the threads. That's one. I'll do the others off camera. And there we have it. The dummy load is now complete. I've written on there 8 ohm dummy load, 80 watt max, just to remind me. Should test it every time before use, just to make sure that it is still at 8 ohms. And see, the thing is, if you put too much power through it, too much amperage, what can happen is one of those resistors can go open. And if that happens, the resistance is going to change on the chain. So it most likely will be one of the 2.2 ohm resistors that will go open first. So you end up with like 28 or well, actually 30 ohm or something on there. But you just test it each time before using it. And this is what I would call the poor man's dummy load, even though it cost about 50 bucks to make. Anyway, I'm the Astro 30. Thank you, Danish Dart, for the soldering iron. Legend. And remember, if you like this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook, and you can also become a Patreon. Anyway, this is the Astro 30 saying, see ya. I'll see you in the next video.